Understanding the nature of time and light time is one of the most mysterious and fundamental aspects of our universe. It flows forward, and everything that exists experiences this flow, or so it seems. But what happens when we approach the ultimate cosmic speed limit, the speed of light? The idea that time ends at the speed of light is a fascinating question that sits at the intersection of physics, philosophy, and human imagination. According to Albert Einstein's theory of special relativity, as an object moves faster and faster, time slows down for it relative to a stationary observer. This phenomenon, known as time dilation, becomes extreme as the object nears the speed of light. In theory, if an object could reach the speed of light, something only massless particles like photons can do, time for that object would appear to stop entirely. But does this mean time ends at the speed of light, or is this simply a misunderstanding of how relativity works? To answer this, we must delve deeper into what we mean by time, how it is affected by speed, and what it means for time to stop from a relativistic point of view. The physics of time dilation and light speed in Einstein's special relativity. The equation that relates time dilation to velocity is derived from the Lorentz transformation. This equation shows that time slows down for an object as it approaches the speed of light relative to a stationary observer. For instance, astronauts on a high-speed spaceship will age more slowly compared to people on Earth. The closer they get to the speed of light, the slower their experience of time becomes. At 99.99% the speed of light, time might pass just a few seconds for the traveler while years pass for someone on Earth. At exactly the speed of light, the mathematics suggest time would stop entirely, but only from the perspective of the external observer. This does not mean time ends in a literal sense. Rather, time becomes undefined for something moving at light speed. The problem is that nothing with mass can reach the speed of light, because doing so would require infinite energy. Only massless particles like photons can travel at light speed, but they do not experience time as we do. From a photon's perspective, say if we can even use that word, the journey from one end of the universe to the other takes zero time. But since photons don't have consciousness or an internal frame of reference, it's not accurate to say they experience no time. They simply exist in a state beyond time as we understand it. Philosophical implications. What does it mean for time to end? To say time ends at the speed of light implies that time is like a line that gets cut off at a certain point. But from a philosophical standpoint, this is a misleading way to look at time. Time is not a separate force or dimension that can suddenly vanish. It is a measure of change, motion, and sequence. What we observe as time is deeply tied to how we interact with the world around us. If a photon travels from a distant star to your eye and experiences zero time in doing so, does that mean it somehow skipped time? Not exactly. It simply means that in the framework of relativity, the space-time interval along a light-like path is zero. This challenges our intuitive understanding of causality and duration. If time is not absolute, and relativity tells us it isn't, then the experience of time becomes relative to the observer. So when we say time stops at the speed of light, we're not saying time has an endpoint. Rather, we're saying time behaves in a radically different way when extreme velocities are involved, to the point where our everyday language fails to describe it accurately. This pushes us to think beyond common human perception and into a domain where physics and philosophy must work together. Can we ever reach or exceed the speed of light? Another aspect of the question involves the possibility of reaching or exceeding the speed of light. As per current physical laws, particularly Einstein's equations, nothing with mass can ever attain the speed of light because the energy required becomes infinite. This forms a kind of cosmic speed barrier. If we accept this, then no observer or object can ever directly experience what happens at the speed of light, because such a state is unachievable. So, if time, at light speed, it is not an end we can ever reach or observe firsthand. Interestingly, some theoretical frameworks, like tachyons, propose particles that always move faster than light, but no experimental evidence has ever supported their existence. Furthermore, even if faster than light motion were possible, it would likely violate causality, meaning effect could precede cause, which would throw our understanding of time into chaos. These possibilities remain speculative and controversial. Thus, our current understanding suggests that reaching the speed of light is like reaching the edge of a map, not because it's truly the end, but because our tools, equations, and language no longer apply in the same way. A boundary of human understanding. In conclusion, the idea that time ends at the speed of light is not literally true. Rather, It reflects the limitations of our understanding and the strange, counterintuitive nature of relativistic physics. Time as we experience it slows down drastically as one approaches the speed of light. At light speed itself, time becomes undefined for anything traveling at that velocity, like photons. But since no object with mass can reach that speed, the experience of time stopping is not something we can physically attain. More importantly, this question forces us to re-evaluate what we mean by time. In the first place, it pushes against the boundaries of classical thinking and invites us to adopt a more nuanced, relativistic, and philosophical view of reality. Ultimately, the question is not just about physics, it is about how we conceive of existence, motion, and change. Asking whether time ends at the speed of light opens up deeper questions about the nature of the universe, and in doing so, reveals just how much more we still have to learn.